this video we're going to look at x and y intercepts, and we're specifically going to look at them when it deals with lines, so like a linear equation, something like that. So now, first of all, let me give you an understanding of what an x and a y intercept actually is. So I've given you 2 points over here on this graph, and you'll see that one point is on the x-axis. So that point is, we'd say that's 3, 0. And then this point right here is on the y-axis, and that point is 0, 2. All right? So just to get a general understanding, an x-intercept is on the x-axis. So actually, we could say the x-intercept here would be 3, 0. So that would be the x-intercept. All right, now the y-intercept, same exact thing, except now it's on the y-axis. So here we could actually say that 0, 2 is the y-intercept. Now, let's say I told you to find both of those without the graph, because when you have the graph, it's pretty easy. You can just say, okay, well, I know 3 zeros on the x and 0, 2 is on the y, so 3 0 is my x-intercept, 0, 2 is my y-intercept. I think we can all see how easy that is. The issue is going to be, though, how do I go about doing this algebraically? Meaning, if there's no graph, how do I go about doing this? All right, now, I want to try to get you to conceptualize this, because once you do, it's a lot easier. So for the x-intercept, let's ask ourselves this question. Will this y value always be the same for an x-intercept? What I'm actually asking you is this. What is the y value for any point that's on this x-axis? Because it will actually always be the same y value. That y value would be 0. So when we solve or find the x and y intercepts with no graph, when we're looking for the x-intercept, we just say the y value is going to be equal to 0, and then we can solve. All right, now let's look at the y-intercept. So once again, let's look at every single point that's ever going to be on this y-axis. So it could be all the way here. It could be exactly where our point is at 0, 2. All those y values will be whatever they are. It could be 0, it could be 2, 4, -2, whatever. But will the y value, will the x value always be the same? And the answer is yes. If you notice, all those x values are just going to be 0. So for the y-intercept, we just set x equal to 0, and then we solve. So let me rewrite all that just to give you the basics. So to find an x-intercept with no graph, you're going to say y is equal to 0, then solve. For the y-intercept, you're going to say x is equal to 0, and then solve. So hopefully, now that we looked at the graph and tried to logic through it, hopefully it makes a lot of sense. So let's actually look at some problems. So let's say I have y equals 5x minus 1. And your job is to find two things. The x-intercept, and then we want to find the y-intercept. All right, and I like to split these up and just do them separately. So once again, an x-intercept is always going to have this form. It's always going to be the x value, comma, 0. That's the ordered pair. So if we take that into account, we're just going to say, well, the y is going to equal 0, and then we're going to solve this problem. So now if I take this equation and bring it down, y equals 5x minus 1, I'm just going to take out the y and replace it with 0. So I'm going to say 0 equals 5x minus 1. And now I'm just going to solve the equation. So I would add 1, and I'll do this fairly quickly. 1 equals 5x, and then I would divide by 5, so x equals 1/5. Now, to technically write our answer, we need to just replace this 1/5 and substitute it in for x. So our actual x-intercept is going to look like this. It's going to look like an ordered pair, 1/5, 0, and that would be my answer. All right, so now let's look at the y-intercept. Now the y-intercept is always going to have this setup. It's going to look like 0, comma, y. So whatever that y value is, I could just replace x with 0. So now, if I take my equation once again and bring it down, I'm just going to take out this x value and replace it with 0. So y is equal to 5, replace x with 0, and I would plug that into parentheses, minus 1. Now, 5 times 0 is just 0, so y is equal to negative 1. But once again, that's not really my answer. I have to substitute this negative 1 in for y, so my actual y-intercept would be 0, negative 1. All right, let's look at another problem. Let's say, we'll say y is equal to negative 6 over 5x plus 2. So once again, I like breaking it up. I like making a column over here that says y-intercept, and then a column over here that says, or x-intercept, and then a column that says y-intercept, and just splitting those up. So now, once again, for the x-intercept, my coordinate, my ordered pair would be x0. So x is going to be equal to 0 in this equation. And actually, I'm doing that backwards. Y would be equal to 0. My bad. So then this y value is going to be replaced with 0. So we would say 0 equals negative 6 over 5x plus 2. And now my job is to solve the equation. So I would subtract 2, subtract 2. Negative 2 is equal to negative 6 over 5x. And now if you remember, if I have a coefficient that is a fraction, I can multiply by the reciprocal to get rid of it. So I'm going to multiply on both sides by negative 5 over 6. So then that's going to leave me with my answer 5 over 3 equals x. All right, so now, once again, my ordered pair, though, is my actual answer. And my ordered pair would be 5 over 3, comma, 0. That's the actual x-intercept. Now, let's look at the y-intercept. So the ordered pair would be 0, y. So that means I can say x equals 0 and replace that x value in my equation. So y equals negative 6 over 5x, but I'm going to replace x with 0. And I'm going to multiply that plus 2. Good thing about this one is that's going to cancel, so y equals 2. But once again, that's not fully my answer. I have to put my answer as an ordered pair, so it would be 0, 2. And that would actually be my answer. Let's look at just one more. That way you can get an understanding of this setup. So you could see a setup that looks like this. 4x minus y equals 8. And basically, in this setup, now we just don't have our equation in slope-intercept form. But here's the good thing. We don't need this to be in slope-intercept form to find the x-intercept and the y-intercept. We can just go through our process. So once again, if it's an x-intercept, that means that y is going to equal 0. So I'm going to do my problem. I'm going to say 4x minus 0 equals 8. That means that when I simplify, I just end up with 4x equals 8. Then I'm going to divide by 4. And now I'm just solving. And the good thing for you is most of us are pretty good with the solving. But now, once again, don't forget, your ordered pair is actually the answer. So the ordered pair, if x equals 2 for the x-intercept, would be 2, 0. And then the y-intercept, once again, we're going to replace x with 0. So now my ordered pair is going to be 0, y. And that just means I'm replacing x with 0 right here. So 4 times 0 minus y equals 8. That's going to cancel. 4 times 0 is just 0. So negative y equals 8. All I would have to do is divide by negative 1 here to get rid of that negative in front of y. So y equals 8. So now my final answer, once again, is an ordered pair. And the ordered pair would be 0, 8. So once again, in short, here are the steps, or here's the main takeaways. If you want to find the x-intercept, and you want to do it algebraically, you have to replace y with 0. If you want to find the y-intercept, you're going to replace x with 0. And if you keep these two things in mind, it's pretty much your blueprint for how to find the x and the y-intercept of any graph.